This next section, we're leaving right angle triangle land and moving into all triangle land. So if you don't have a 90-degree angle in your triangle, you need to use either the sine law or the cosine law. So this section is going to introduce us to the sine law and the cosine law, and each one gets used in different applications. So the sine law, it's all about is the sine law is used when we know an angle across from a side and one more piece of information. So the sine law, we would have, angle B and side B, and one more piece of information, either another angle or another side. In your formula pages, there's two iterations of the sine law. So the sine law just says that there is a ratio between side A and the sine of angle A, or side B and the sine of angle B, or side C and, you guessed it, the sine of angle C. You can also, in your formula pages, it has the upside down version of these. Now, technically, it could be argued that if you don't want an unknown in the denominator, as we've seen, that can potentially be a problem. Maybe you want the other option. I tend to go with just the top one. I find that works best for me. You really can use either one, so either way. Okay, if you use the sine law, you can pick any two of the three. So you don't need all three ratios, but you can know that they're all proportional, and so you can pick and choose. And you don't need all of them because they are all proportional. And hopefully, now that we've been through your rates section, ratio and proportion, and also the geometry unit, we've been seeing these proportional, and we used it in similar triangles. So let's take a look at these. So this is the first case. We want to find a side here. What we have is angle A and side A. So when you have that, that's what sets you up for the sine law. So we want to find side C in this one. I kind of made that one up. We have angle C. So what I would be doing is setting up my equation, side A over sine of A, and side C over sine of C should be proportional. I have my equation. Now I can sub in what I know. Side A is 6, and sine of 56 corresponds to the bottom part there. C is what I'm looking for. That's my unknown, but I do know angle C. So sine of 72 is what I'd have down below. So you can set this up in any which way, right? Like if you use the other upside down version. In solving for C here, I simply do 6 times the sine of 72 divided by sine 56. And now we know that we can put these into our calculators just like a number, right? So I'm going to write it out in this one, but I don't often. So C would equal 6 times sine of 72 divided by sine of 56. If you need to write this step, go for it. If you don't, that's absolutely fine. Hopefully you're not still puzzled on how to get there. And I do this next step on my calculator to give me my answer that side C is 6.9, whatever units those are. We're still going with 1 decimal place on sides and angles to the nearest degree. So that's how we use the sine law, and when we use the sine law, and how we solve for a missing side. The next one is solving for a missing angle. So we need to label up this triangle a little bit. We've got triangle P, Q, and R. And I know some information. I know that this is 115 degrees here. I know that side R is 4.5 centimeters, and I know that side Q is 10.8 centimeters, right? This is Q, and this is r. We would like to solve for angle r. That's what we're looking for. And the key thing with this is that we know an angle across from a side. That means that we can set it up so that q over sine q would equal r over sine r, right? Same, the letters are different, but this idea that they're proportional is really what the sine law hinges on. So subbing in what I know, q is 10.8, angle q is 115, so sine 115 goes on the bottom, 4.5 is going to go on the top, and sine r is going to go on the bottom. So setting this one up, I could cross multiply. I could do whatever. I would have that sine r is equal to sine 115 times 4.5 divided by 10.8. I didn't in my key write that out as a step, but that's what you'd put in your calculator. The other thing to remember is to use that second function button. We want to solve for the missing angle. So this holds the same. If we want to pop that out, we have to actually use the inverse sine function. And so r on my calculator works out to, rounding to the nearest degree, 22 degrees. Let's see this in action. We've got a triangle here. We know that we've got this angle and the side across from it. We have this side, but we don't have either of the other two angles. So what I'm going to do first is solve for angle C. And if I have that, then I'm going to get a little bit closer to solving this triangle. So setting this up, I would have b over sine b is equal to c over sine c. 6 down here is side c. So subbing everything in, I'd have 9 over sine 105 and 6 over whatever sine c is. I just did this on my calculator, pulling out that angle c is 40 degrees. The next thing you could do is take that lovely gem of a law that 180 minus 105 minus 40 would give you what angle A is. So A, in this case, is 35 degrees. We're getting closer, and this is a bit of a smaller diagram, so I'm not scribbling on it kind of as I go. The last thing I would have to do is to solve for side A over here. So I'm going to use the sine law again. This time I'm going to say that side A is over the sine of 35. Or sorry, I'll write out the equation first. I got ahead of myself. A little easier for you to follow maybe. Is equal to, let's go back to what we were given, b over sine b, right? This is given to us. So we're not going to perpetuate any rounding errors, and it's always best to kind of go back to the original as much as you can. So I would have a over sine 35, remembering that's what I solved, angle A to B, is equal to 9 over sine 105. I would have that A equals sine 35 times 9 divided by sine 105. I had the space, so I did it on this one. I usually just do that on my calculator. I get that side A is 5.3. So that's really solving the whole triangle using the sine law a couple times, but also going back to what we know, right? The easier ones. So the cosine law is a little bit more cumbersome. I would much rather use the sum of the angles as 180. I like Pythagorean, I like SOHCAHTOA, but if I can't use any, then I like the sine law. Cosine law is probably my least favorite. So the cosine law is used when you do not know a side across from an angle. Oops, I think I got those A and an. Either way, same idea. The cosine law can be used to find a side when you know two other sides and an angle. Oops, sorry, this should be SAS, that bracket should be in there, and an angle, when you know, oh sorry, really messing this up. and to find an angle when you know no angles but all three sides. So we either know side, angle, side, or we know all three sides, one or the other. Those are the realities that we have to use the cosine law. So like I said, I'd much rather use the sine law because I find it a little bit easier to manage than these. And there are three versions, and oftentimes I like just deriving them, but this case, no. So these would solve for a missing side, remembering that we'd have to take the square root of all that, right? And these would solve for a missing angle. And remember, you'd have to use the second function to pop out the measure of the angle. So those are in your formula pages. You do not have to have them memorized. You do have to be able to use them. And sometimes in your calculator, the calculator skills are a little tricky. The other thing is that sometimes you'll get a negative. So if you get a negative, don't worry, your calculator is going to make sense of that. You won't get a negative on this side, but you might get a negative is okay. I know when I was doing the work, it's alarming. If you stay the course, and I'll try and give you the heads up when we have that happen. I think it actually happened in the assignment pages. Okay, let's try one of these ones. So the first one here says use the cosine law to solve for side B. So this is the case where we have a side, angle, and a side. We don't have enough information to go off for the sine ratio. We also don't know that we have a 90-degree triangle, so we can't use SOHCAHTOA. So in these ones, if I want to solve for side B, the equation solving for side B is that B squared equals A squared plus C squared minus 2AC cosine of B. It really doesn't matter what these are. If you have a triangle that's labeled differently, and I think this happens in the practice test, I would advise rewriting them as triangle A, B, and C, because that makes it fit these formulas that you're given a whole lot easier. Now that I have this, I can sub in everything that I know. I know that this is A, this is C, and this is angle B. So side B squared is equal to 6 squared plus 5 squared minus 2 times 6 times 5 cosine of 45. So putting this in your calculator is pretty cumbersome. In all honesty, I do this part in brackets as I go through it, and that works pretty well. So I can put in 6 squared plus 5 squared minus, put in that bracket, type all that in, end your bracket, and then don't forget to take the square root when you're all done this. So all of that work can be done on your calculator. Give it a try. B would equal 4.3 on my calculator. Now that we have that, we're going to use, again, the cosine law to solve for angle C. So the equation that solves for angle C, I'm just copying it from my formula pages. And then I can sub everything in that I know about. So I'd have cosine of C equaling A is 6 squared plus 4.3. I needed that from up top here, right? Minus 5 squared all over 2 times 6. Oh man, this is a subbing in nightmare. Times 4.3. Okay, so on my calculator, I can do all of this. I can do the top and then hit equals, and then divide by each of these things on the bottom. So divide by 2, divide by 6, divide by 4.3. Or I can do the thinking for my calculator and do the top, hit equals, and then put all of this in brackets. Either way, remember that you also, to solve for that missing angle, you have to use the second function. Second function, right? So all of this on your calculator, it feels silly to not show my work. C ends up being 55 degrees. I think as an intermediary in my answer key, I actually have like what the top equals and then what the bottom equals. If you're not comfortable with the brackets, that is a valid way to get to the right answer. It just takes an extra step. So regardless, you should get down using that second function, the inverse cos function, to side C, or sorry, angle C. The last one is to answer what is angle A. So in that one, we could just take 180 minus the 45 that we knew and minus the 55 to get that angle A is 80 degrees. All right, it's a whole heck of a lot of work using the cosine law. We've got one more here to do. And it says, use the cosine law to solve this triangle. So this is the reality of having a side, side, side. So if I want to, I can choose to solve for any angle that I want. I'm going to start with A. So cosine of A, and this is me just copying out the formula, is equal to B squared plus C squared minus A squared all over 2BC. Subbing everything in, it might be worth labeling this because I make mistakes, right? B is 8 squared plus 7 squared minus, oops, I did that wrong. My goodness, see? This is why I try and slow down. What is that? 6 squared and 7 squared all over 2 times 8 times 6. So doing this in your calculator, taking care as you go, use the brackets or the divide by each of the things on the bottom, or do the top, then do the bottom, right? Breaking it up. Remembering to hit the second function, you can solve for angle A as 58 degrees. After that, you could use the sine law, or you could use the cosine law. I'm going to use the cosine law to solve for, let's do this one, angle C. So the equation to solve for angle C, I just copy it off of my pages, is A squared plus B squared minus C squared all over 2AB. Subbing everything in carefully, I'd have 7 squared plus 8 squared minus 6 squared all over 2 times 7 times 8. Using my calculator carefully, oops, sorry, I was going to write that angle C, because this is what I'd probably do next, angle C is equal to 47 degrees. So we already were given all three sides. We've got two of the angles now. The last thing to do is to solve for the third angle. So 180 minus the 58 and minus the 47 should give me that the missing angle is 75 degrees, and that is angle B. So that is the sine law and the cosine law. I much prefer the sine law. The cosine law, I frequently make subbing in errors, and I do find that the calculator work is a little bit cumbersome. So give those a shot and make your choices. So if you don't want to use the cosine law, you can often find a workaround. We have one more section in Unit H, which is the applications of trigonometry.